Okay, so Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, petang. Good evening pun boleh juga lah, tak kisahlah. Apa-apa je. Alang-alang tu good morning sekali lah. Sabar je lah. Okay, so now let me see. It's 4:02. So we got another, I think I better start at 4:05. So kita tunggu sekejap lah. Dalam 3 minit lagi. So sementara tu boleh isi attendance dulu lah. Untuk siapa yang tak isi attendance lagi, so boleh isi attendance dulu. Sekejap. Korang ada ke attendance BKP tambahan? Eh, 3 orang je kita. Hai Farha. Farha, kita 3 orang je Farha. Awak, saya, siapa lagi seorang? Oh, 4 orang dah. Ada orang yang keempat. Hai orang keempat. Oh, 6 orang dah. Oh, 5. Seorang lagi dah terkeluar balik. Kita tunggu 2 minit sikit. Private class. Private class pakai YouTube tau. Lama. Hebat Demo, hebat. Dah hari ni kelas French pula tu. Tajuk French. Macam mana tak dia orang sebut Poisson ke macam mana tak. Tapi tak apalah, kita Malay dia. Poison. Oh, ada 8 orang, 9 orang. Siapa lagi nak masuk? Cik Wah. Hai Hafizah. Okay, sila masuk, jangan malu-malu. Yeah, I think this is the last lecture yang buat hari Isnin kot rasanya. Lepas ni tak ada dah lecture yang buat hari Isnin sebab kita dah nak habis lah. So for the last time, hi everyone. Okay, 4-5 minit dah. Jom kita start lah. If I'm not mistaken, dia punya slide tak banyak sangat. So sepatutnya kita boleh habis agak cepat lah sebenarnya. Okay, so now the learning outcome for today. So this is lecture 2 out of 4. So basically, today we are going to learn only lecture 3. So tomorrow in class we are going to do lecture today we are going to do lecture 2. Tomorrow in class we are going to do lecture 3. And then this coming Thursday we are going to do the last lecture 4. Okay, so now the learning outcome. At the end of the lesson, you should be able to identify the Poisson distribution. So we are using P naught lambda for them. Find the mean and variance of the Poisson distribution, and then find the probability by using the Poisson distribution. Okay, so basically in special probability distribution, we have 3 main things. We have binomial, we have Poisson, and then we have normal as well. So for binomial and Poisson, both of them are discrete random variable. For normal, those are the continuous random variable. Okay, so next. The Poisson distribution applies when the event is something that can be counted in whole numbers. The occurrences are independent. The average frequency of the occurrence for the time period in the question is known, and it is possible to count how many events have occurred, such as number of times a firefly light up in my garden in a given any 5 seconds, some evening, but very meaningless to us how many such events have not occurred. Okay, next. Poisson distribution. Okay, so the Poisson distribution is used to model the number of events occur within a given time interval. So the special thing for Poisson, we have a time interval for them. So situation to be modeled by Poisson distribution are, so an experiment consists of counting the number of times a certain event occur, and then the probability of an event occur is the same for each interval. The event need to occur independently. So if let's say x is the number of occurrence in the given interval, so they are written as x is a Poisson distribution where lambda, we have a lambda over here. So lambda is the parameter of the Poisson distribution, and a special thing about lambda is that lambda should be greater than 0, which means that lambda should always be a positive number. When the Poisson distribution is appropriate, the probability of exactly x occur is given by a formula. So this is the formula for the Poisson distribution. So make sure to highlight this. So this is the formula for the Poisson. Okay, so basically I will use this formula if let's say I want to find exactly what number the x is. So for example, probability for x equal to 1, x equal to 2, x equal to 3, x equal to 4. So if I have any equal sign, so biasanya saya guna formula lah kalau ada equal. If I see something that is greater than or less than, normally for me, I prefer to use the table. If I can use the table, I prefer to use the table. Okay, next. Oops. The mean and variance of Poisson distribution. So basically, if x is a random variable following the Poisson distribution, so x is a Poisson distribution where lambda is the parameter, then the mean and variance of x, so expectation of x is simply equal to that parameter, and variance of x also equal to that parameter. So x is a Poisson distribution, so this one over here is the lambda, and this lambda is the mean, and they are also the variance. So we are going to get the same number for the mean and the variance. Okay. Right, so let us try to do the first example. If x is a Poisson distribution where lambda is equal to 6, so this is the value of our lambda, lambda 6, find the probability by using the Poisson formula. So we are going to use this formula. Px equal to x equal to e to the power of negative lambda, lambda to the power of x over x factorial. So we are going to use this formula to answer question A up until D. Okay, so let us proceed to the first question. Probability for x equal to 3. Okay, so now this is the value of x. So every time you see the x, substitute them with 3, and lambda is actually equal to 6. So lambda is equal to 6, and then the value for x is equal to 3. So this is e to the power of negative lambda, so e to the power of negative 6, lambda to the power of x, so 6 to the power of 3 or 6 cube over x factorial or 3 factorial. And then you can use your calculator, e to the power of negative 6, 6 cube over 3 factorial. Leave your answer in 4 decimal places. So this is 0.0892. Okay, so let us go to the second one. B, probability for x greater than or equal to 2. So this one is a discrete, right? So probability for x greater than or equal to 2, it might be 2, 3, 4, 5, 6, and so on. Therefore, I find it much hassle sebab kita tak tahu dia nak stop dekat mana. So better for us to take the total probability, which is 1, and then we minus with probability for x less than 2. Sebab kita nak yang lebih besar daripada 2 kan. So kita tolak yang kurang dari 2, nanti kita dapat ya yang lebih besar daripada 2. Okay, so 1 minus probability for x less than 2. So x less than 2, that means either x equal to 0 or x will be equal to 1. Okay, so now substitute into the formula e to the power of negative lambda, lambda to the power of x over x factorial. So substitute the value in. So e to the power of negative 6, 6 to the power of 0 over 0 factorial. Yang ni jangan lupa lah, simbol dia ada 0 factorial. Kalau tidak, nanti dia akan jadi undefined. Okay, and then e to the power of negative 6, 6 to the power of 1 over 1 factorial. And then of course, simplify them. So this is 1 minus 0.017352. So the value for them is 0.9826. Okay, so always make sure this is a discrete random variable. So you need to define what are the numbers such that x greater than or equal to 2. So kena tahu nombor berapa lah dia discrete kan. Okay, so now C, probability for x less than 2. Okay, so probability of x less than 2. What are the number that is less than 2? So we can either have x equal to 0 or we can have x equal to 1. So those are the number that is lesser than 2. Okay, so probability for x equal to 0 plus probability of x equal to 1. And then of course you can use the formula e to the power of negative lambda. So the lambda is equal to 6. And then 6 to the power of x over x factorial. Okay, so e to the power of negative 6, 6 to the power of 0 over 0 factorial plus e to the power of negative 6, 6 to the power of 1 over 1 factorial. Okay, so simplify them. So this is 0.0174. Okay, now D, the last one for this example. Okay, so we want the probability for x greater than 3, but x will be less than or equal to 5. So do make sure this is a discrete number. So that means you must know what are the numbers that is greater than 3, but at the same time, it should be less than or equal to 5. Okay, so the value, what is the value? It should either be x equal to 4 or x equal to 5. So 4 is greater than 3, less than 5. And then 5 is greater than 3 and equal to 5. Okay, so I will have two value over here. So probability for x equal to 4 plus probability of x equal to 5. And then again, we are going to use the formula. So e to the power of negative lambda, lambda to the power of x over x factorial. So e to the power of negative 6, 6 to the power of 4 over 4 factorial plus e to the power of negative 6, 6 to the power of 5 over 5 factorial. And then again, you must use your calculator for them and make sure to leave your answer in 4 decimal places. If possible, 4 decimal places. Okay. Should I give you the answer? Okay, let me give you the answer. If you need more time, you can actually pause the video if you want to. Okay, so the answer is 0.1339. Okay, let's go to the next example. Oops, tak habis yang tadi. 0.1339 plus 0.1606. So that is 0.2945. Terlupa pula. The next one yang sebelah sana. Tapi tak apalah. Okay, next. Right, example 2. If x is a Poisson distribution with the lambda or the parameter is equal to 5.5, find probability for x greater than or equal to 5, probability for x less than or equal to 5, probability for x exactly equal to 5, and then probability for x greater than or equal to 3, but it should be less than 8. Okay, so they didn't ask us to use the formula, so that means we can actually use the table for them. So please make sure to ready the table. So make sure the top one, they must write down Poisson distribution table. So mesti kena tengok lah bahagian atas dekat awak punya buku formula tu, atas tu mesti Poisson. Poisson punya table lah. Okay, once you have the table for the Poisson, check where is lambda equal to 5.5. So carilah dekat mana lambda 5.5. And then like usual, you can actually take your pencil or you can use your pen or your highlight, whatever that you have. Draw a box for them. So we know this is belong to the lambda equal to 5.5. Okay, so now how do we read from the table? So let us see the first one, probability for x greater than or equal to 5. Okay, so this is the table. So over here, this is my lambda, lambda 5.5. So this is the table that I asked you to highlight them. Okay, so now we are looking at probability for x greater than or equal to 5. So this is actually similar to binomial. The way we read them is always greater than and equal to. Okay, so that means probability for x greater than or equal to 5, you can directly read from the table. So this is lambda 5.5. So do make sure to find out where is 5. So 5 is over here. So that means the value for them is 0.6425. So this is the probability for x greater than or equal to 5. So straight away from the table, we can get them because the way we read our table is always starting from that point and then going to the right hand side. Okay, so done with the first one. Let's go to the second one. So I want the probability for x less than or equal to 5. Alah, kacau pula. Okay, right. Probability for x less than or equal to 5. Right, so this is 5, this is 6. So we want them to be less than or equal to 5. So that means I want starting from 0 up until 5. So I want this region. So what am I going to do is that I'm going to take the whole probability, which is equal to 1, and then I'm going to minus starting from 6 going to the right hand side. So once I minus 6 going to the right hand side, I will directly get the 5, 4, 3, 2, 1, and 0. Okay, so what is probability for x greater than or equal to 6? So the 6 is over here. So the value is 0.4711. Okay, so you're going to do the total probability, which is 1 minus 0.4711. Okay, sekejap. Saya hilangkan tu. Kalau tidak tak nampak nanti. Okay. So 1 minus 0.4711. So the answer for them is 0.5289. So that is the probability for x less than or equal to 5. Okay, see, we have probability for x exactly equal to 5. So if you want to, you can use the formula. So this is e to the power of negative lambda, lambda to the power of x over x factorial. So this is probability for x equal to x. So you can actually use this formula because we have the equal sign, or we can use our table as well. Okay, so how to use the table? Alright, so we want probability for x equal to 5. Okay, so if I draw a number line over here, this is 5, this is 6. So I want them to be exactly equal to 5. But the way we read our table is always to the right hand side. Therefore, I need to get x greater than or equal to 5. And then I will minus them with x greater than or equal to 6. So kita ambil yang ke arah kanan ni, lepas tu kita buang 6 dan kita akan dapat 5 seorang-seorang lah. Okay, so probability for x greater than or equal to 5 minus probability for x greater than or equal to 6 to 0.6425 minus 0.4711. Okay, so simplify them. So the answer will be 0.1714. Okay, next. D. Okay, so D. I want the probability for x greater than or equal to 3, but it should be less than 8. Okay, so based on my number line over here, so this is 3, 4, 5, 6, 7, 8. Okay, so I want them to be greater than or equal to 3. So maksudnya nombor 3 saya nak. Number 4, I want them. Number 5 as well. Number 6, number 7. But I don't need the 8. So what I will do is that I will take the probability starting from 3, going to the right hand side. So I'm taking everything. And then since I want up until 7, so that means I need to delete the 8 and going to the right hand side. So this is probability for x greater than or equal to 3 minus probability of x greater than or equal to 8. Okay, so now greater than or equal to 3, 0.9116 minus greater than or equal to 8, 0.1905. Oops. So that will be equal to 0.7211. Okay, so done with the second example. Let's see how many examples do we have. Okay, we have 6 examples. That should be okay, I think. I can finish them. Okay, next. Right, example 3. If x is a Poisson distribution with the parameter equal to 4, find the mean and the variance. Okay, so if you refer to the note that I gave you previously, the lambda is actually equal to the mean, and lambda is actually equal to the variance. Okay, therefore, if the question asks for the mean, then the mean or the mu is exactly equal to 4, which is our lambda, and then the variance is also equal to 4. So they will have the same value both for the mean and the variance. Okay, next. Right, example 4. Given that x is a Poisson distribution with mean lambda, so they didn't really tell us what is the value for the mean. But never mind, from here I can easily write down x is a Poisson distribution. So I got lambda over here. If probability for x equal to 2 is equal to 2 times probability of x equal to 0, find the value of lambda. Okay, and then calculate the probability for x equal to 2. Okay, so firstly, I need to take this one and substitute into the formula. Okay, so probability for x equal to 2 is equal to 2 times probability of x equal to 0. And then we are going to use the formula. Probability for x equal to x is equal to e to the power of negative lambda, lambda to the power of x over x factorial. So if we have x equal to 2, so this is e to the power of negative lambda, lambda to the power of 2 over 2 factorial, and then right over here we actually have a 2. So 2 multiply with e to the power of negative lambda, lambda to the power of 0 over 0 factorial. And then you're going to bring the 2 to the right hand side and then divide everything with e to the power of negative lambda and make sure you have lambda square as the subject. Okay, so now let us simplify a little bit. So lambda to the power of 0 is equal to 1, 0 factorial, that is also equal to 1. So I have e to the power of negative lambda, lambda square over 2 factorial equal to 2 times e to the power of negative lambda. And then these two, they are actually similar. So I can either bring it to the left hand side or I can bring it to the right hand side, bring it to the left or bring it to the right. They should cancel each other. So that means I will be left with lambda square equal to 2 multiplied with 2 factorial. So lambda square is equal to 4. Therefore, lambda will be exactly equal to 2. Okay, so actually, if we have a square over here, they should be a plus and minus. So lambda square is equal to 4 and lambda can be plus or minus 2. However, if you refer to the note that I gave you previously, I did mention, right, the value of the lambda need to be always greater than 0. The parameter cannot be some negative number. So the parameter should be a positive number. Therefore, you cannot accept negative 2. So the lambda can only be positive 2. Okay, so now I do know the value of the lambda. Lambda is actually equal to 2. So now we are going to find out what is the value for the probability of x equal to 2. So let us substitute into the formula. So this is e to the power of negative 2, 2 to the power of 2 over 2 factorial. Okay, so make sure you use your calculator and then you must leave your answer in 4 decimal places again. So this is 0.2707. Done with example 4. We are left with another 2 example. Okay, next. Okay, next Right. So an average of 3 cars arrive at a highway every minute. Find the probability exactly 5 cars will arrive in 1 minute. Okay, so we have an average of something. So this value over here is the average or actually the mean. So mean is actually equal to lambda. So what we can say is that x must be a Poisson distribution where the lambda is equal to 3. Okay, so remember Poisson, we need to have some interval for them. So x is the number of car arrive in 1 minute. So always make sure you write down the interval. That will help you a lot if you have A, B and C. If you have more than one question, that will help a lot. Sebab kadang-kadang soalan tu dia minta part A, part B. So kena tahulah interval dia berapa. Okay, so now exactly 5. What does exactly 5 means? Exactly 5 means that mean probability for x must be equal to 5. Okay, so probability for x equal to 5, of course, you can use the table for them. But normally for me, if I have an equal sign, I normally prefer to use the formula. So I will use e to the power of negative lambda, lambda to the power of x. Should I write them down? Tulislah, nanti kalau kau tak ingat. E negative lambda, lambda to the power of x over x factorial. Okay, so e to the power of negative lambda, so the lambda is actually equal to 3. So e negative 3, 3 to the power of 5 over 5 factorial. Okay, so again, make sure to use your calculator for this. So the value for them is 0.1008. Okay, so now we have already reached the last question for today. So sekejap je lah, tak sampai 45 minutes pun. Habis lah. Okay, example 6. An average of 6 telephone calls are received by department every hour. Find the probability that 4 calls are received per hour, the probability that 6 calls are received in 2 hours, the probability that less than 3 calls are received per 30 minutes. Okay, so now average of 6. So that means the value for the lambda for this one is actually equal to 6. And this one is for 1 hour. Because it say over here every hour, so that means the average is only for 1 hour. Okay, so now the probability 4 calls are received per hour. So that means we are looking at probability for x exactly equal to 4. So you can use the formula e to the power of negative lambda, lambda to the power of x over x factorial. So the value of the lambda is equal to 6. The value of the x is equal to 4. So make sure of that. Okay, so e to the power of negative 6, 6 to the power of 4 over 4 factorial. So the answer for this is 0.13385. Okay, the second one, the probability that 6 calls are received in 2 hours. Basically, if you read the question, you should be able to see that now we are changing our interval. So for this one, we have 1 hour where the average is equal to 6. But this one, we have 2 hours. So you must change your average as well. Lambda equal to 6 is for 1 hour. So basically, if you have 2 hours, then the lambda will be times by 2. So that means the new lambda is actually equal to 12. Okay, so the new lambda, 6 times 2 equal to 12. So why do we have to change it to a new lambda? This is because the interval changing. So previously we have only 1 hour. This one, the interval is 2 hours. So I need to modify the average according to the interval. Okay, so now 2 hours, I'm going to times them by 2. So 6 times 2, this is equal to 12. So I got a new one. X is a Poisson distribution where the mean is actually equal to 12. And then we want to find the probability 6 calls are received. That means I'm looking at probability of X exactly equal to 6. Okay, so of course, you're going to substitute into the formula e to the power of negative lambda, lambda to the power of x over x factorial. Okay, so find out what is this value. So the value is 0.0255. Okay, C, the last one. The probability that less than 3 calls are received per 30 minutes. Per 30 minutes. As you can see, we change the interval again. Okay, so now can you tell me what is the value of your lambda? What is the value for the new lambda? Lambda dia berapa? Cepat. Cik tulis. Alang-alang soalan last. Last ni baru nak tanya. So lambda is equal to lambda equal to 3. Congratulations, you got them right. Betul lah tu, kita boleh faham lah tu. Okay, Jun. Let us start. Let us end this. Okay, nak habis dah. Sikit je satu lagi. Lambda equal to 3. Betul. Syabas. Dina pun betul. Pong pun betul. Dira pun betul. Aisyah pun betul. Okay, so semua dah betul. Fatha pun betul. Okay, so let us answer C. Okay. Right, so the new lambda is actually equal to 3. So you guys got them right. And then we are looking at probability for x less than 3. Okay, so x less than 3, that means this is probability for x less than or equal to 2. So I can calculate probability for x equal to 0 plus probability of x equal to 1 plus with probability of x equal to 2. And then we can use the formula for each of them, where the formula is e to the power of negative lambda, lambda to the power of x over x factorial. If you don't want to, you can actually use the table as well. That is fine. Okay, so now I think I'm gonna use the table. So this is 1 minus probability for x greater than or equal to 3. So this is 1 minus 0.5768. So the answer for this is 0.4232. Okay, so if you don't want to use your table for this one, you can actually list them out and then find out the value for them one by one. So find the probability for x equal to 0, x equal to 1, and x equal to 2, add them together, and that should be the same answer with this one. Okay, so I think that's the end of the second lecture. So I'll see you guys tomorrow. So tomorrow we are going to start with a new subtopic, which is the normal distribution. So goodbye everyone. Have a nice day. Bye bye.